So I have opened these assignments a while back. It's not due. This one is due the end of this week, and then Unit 13 is for next week. We pushed back 1 week because of the outage. So in this particular area, you need to know how to be able to assess Internet of Things. Did you need help?
Yeah, the other computers were on power saving mode.
Oh, yeah, you just have to change the input. Yeah, and it's not working. Yeah, this one was having an issue yesterday too, so yeah, let me get them to check on it this weekend. I'll put in a service ticket. Okay, so Internet of Things encompasses your um smart devices. A lot of the times now they are built with narrow AI, which is like your Alexa, if you use your smartphone Siri, that would probably be one of the component now that they um are a little bit more intuitive as they would be able to provide you with the resources that you're inquiring, right? Or asking for, requesting. So one of the things that you need to know when you are pen testing IoT is that you need to understand the hardware. A lot of the processor are very limited to the task that it's performing. Many of them are embedded systems. So the difference between microcontroller and embedded systems is that microcontroller, the processor is really running functions, whereas embedded system, very much like your cable box, um, it has an operating system that's running in the back or the software tools that you need to be able to access menu, to be able to go through the configuration and so on. So in IoT devices, it's important that we understand the hardware. The big area for IoT attacks is that a lot of them don't have adequate firmware to be able to be more secure. In industrial automation system, embedded systems are typically used to be able to streamline the operations for the business. So what you see is that a lot of these things can tie back into the industrial systems. So the first question is that why are IoT devices prone to cyber attacks? It's because there is a lot of lack in security measures in IoT. IoT is fairly new in the industry in the integration with business use. So what you see is that a lot of them don't have fast enough updates for their firmware software and also um, in the application itself, right? If you use Android systems, you typically see that they push update regularly, only because there is a lot of security changes in a lot of the software packages that you're using. So embedded system like Android systems, like if you're looking at just like a tablet or a smart device, typically, they're designed to interact with the user, providing the user what they need. But all IoT devices are connecting to a network, mostly wireless network. So with that, there is vulnerability in itself, right? So in some cases, if you're looking at surveillance camera or IP cameras, as they call them, right? They are very specific for that functionality. Um, as it stores your video and then transmit that video into a server or a repository where a user can later retrieve it via the app. So in that, you do have some design lacking, and it makes the IoT devices are more vulnerable to a lot of these attacks. So in itself, you do see a lot of vulnerability that can be exploited. And they have exploitation kits specifically for the IoT area, depending on the type of IoT that they're really targeting. So if you're looking at hospital, they're using a lot of IoT mouse to monitor like vital signs, patient's heart rate. Even they're using some automated system for like medications, things like that. So what you see is that all of these devices are interconnected, and typically, all IoT devices would have some form of processor. So when you're looking at Android systems, as part of IoT devices or embedded systems, typically runs embedded Linux. Um, they would have your ARM type of processor, so reduced instruction set type of processor. These processors are instructed to be at low level, right, to possibly receive input, to be able to provide some kind of output, possibly on a screen, or some kind of console or terminal. And then you have the typical storage. A lot of them have larger internal RAM, as what you see with a lot of the smart devices, right? It doesn't really have extra secondary storage like SSD, like a regular computer. So your RAM is utilized for the software functionality to be able to have the application that you need for the user purposes. So if you're looking at the TV cable box, which is like a typical system that you see, and in some of the cable boxes, right, that's an embedded system. It has menu options. You're able to operate it with the remote control. A lot of it is really pulled from RAM or a Roku, right, or those Fire Stick. So those are the IoT devices that we typically see now in the household. Google Nest, smart thermostat, surveillance camera, and so on. In a lot of cases, what you see is that all of these IoT devices can be detected by using a search engine like Shodan. So in that, you have a lot of data type of exchange and services. So if we're looking at IP camera takes video capture when the motion is activated typically, right? Or the original system would be like CCTV. They are connected to the network, like Ring is typically the device that a lot of people install. So they have an IP address. They are usually wirelessly connected or wired connected. They have a lot of data exchange. So whatever the video capture is, it packages it and then you can put it on the cloud. And then if you want to use encryption services, you have to pay extra for that. Um, and all IoT devices have some form of interfaces. So whether it's a touchscreen that you typically use to navigate, or it might have some kind of console, so that way the user can interact with it. So at the very basic level, these are the major components that you see. But the most important area for cybersecurity people is the firmware, right? So firmware are usually just packages so that way the instruction for the systems can be executed in a certain for a certain purpose. So if you're looking at Alexa, right? Alexa has a capability to have a microphone and a speaker. You can tell Alexa to play music, or you can tell Alexa to give you some kind of information. So with that, it needs the firmware to be able to communicate to the hardware, so that way the microphone can turn on when you say a specific keywords, right? I was looking into like how they train these type of system with verbal type of cues, right? The modeling for that is a lot harder than what we typically expect. So the accuracy in speech and how you speak to it in different tones and different accents and things like that. So over time, these things can be important when you're looking at like down the line how AI can play into IoT devices, because they already are in there, right? Okay. So based on the given scenario for question 3, the first scenario, the attacker intercepting communicating between a smart health monitoring system and the hospital server to exfiltrate sensitive health data of the patient. So in the case where if the attacker is using, right, a technique to be able to intercept. So the keyword here is intercepting. And in the case of interception, their purpose is to be able to receive the data that is communicated from the smart monitoring system to the server, right? So they become the middle man, the middle system that is intercepting communication between the health monitoring system and the server. So with that, what you see is man-in-the-middle attack typically happens with IoT devices if they want to be able to pull the data. This is happening a lot in healthcare. Healthcare has concern about ransom, and healthcare has concern about IoT devices that are being used. A lot of hospitals are switching over to smart devices to really streamline the services. Like the nurses don't have to there will be less nurse monitoring where they can centralize a lot of that. Um, in the second scenario, the attacker overloads the wireless network with SYNAC attacks. So whenever you see overloading and SYNAC, you already know it's denial of service, right? We talked a little bit about that in the past, where denial of service attack typically just plays on making the centralized access point or the wireless router become unavailable. And they need to be able to sniff out your traffic in order to perform it. SYNAC attack is a way that they can just generate packets so that way it's so busy handling your packet that it becomes unavailable. Now, if you're monitoring your network effectively, this should not be a problem. And if you're controlling it with security rules and appliances, right, it should reduce the risk for that. But attacks still happen, denial of service still happens. It's a very common form of attack. So in the case that if they wanted to take that wireless network off because everything connected to that wireless network will become unavailable for communication, right? Because it's a centralized area. So for C, when the attacker exploit unpatched vulnerabilities in the software for IoT devices, like your operating system, right? Like Android, or a previously unknown cybersecurity engineer to cause industrial IoT systems become malfunction. So exploitation can start in 0 day. That means that even that product before it gets utilized in the consumer world or even sold in the market, right? They already have the attack for it because it comes with hardware or software vulnerabilities. So in a lot of cases, we do see that there are a lot of vulnerabilities that are coming from the operating system side because these devices are running embedded Linux. So a lot of people say that Linux is more secure than Windows system. It's just that Windows tend to have more threads that are written for it, right? Because there's more usage in Windows operating system in the world. But Linux and Mac OS, they typically also have vulnerabilities in the software, right? Like there's no software that's 100% secure and 100% perfect, right? Because otherwise we would not have new devices and new technology to be able to accommodate the transition from the lack of into something that's a little bit better. So the improvement in technology is really a drive based on the lack of in the existing technology. So you see 0 day attack, and the keywords here is that previously unknown, right? And because industrial system, a lot of them utilize older operating systems and then older type of protocols and services for communication. So you typically see, right, even for the newer devices, what you see in development and in the engineering process for it, they don't always adapt so quickly because industrial system, in order to update, you have to take them down. And when you take them down, sometimes, that creates outages for a section. So what do I mean by industrial system and how do you actually see it, right? If you drive around town and if you look up at some of the lights, right, a lot of the city now have access point for the public use. These are industrial access point or your wireless router. They are typically come with like a solar panel or some kind of very low power management type of system, right? So, and in communication company, you see industrial routers that are being used for network communications. So these are devices that can be controlled, but IoT devices are just everything that connect to the internet, right? And typically we call them smarter things because the internet allows you to have communication and data and all of those things. So in 2023, a hidden backdoor was installed in a firmware Taiwan-based motherboard manufacturer Gigabyte. I'm sure some of you are familiar with their motherboard, right? That allowed hijacking installation of malicious code, and this is considered a firmware manipulation, right? So the motherboard itself, right, already have this problem. And so when the people buy it and they install it on their system, right, the malicious code is already in existence. Um, there's a lot of concern about some product that is being imported from overseas, about firmware that is not being patched, and about potentially malicious code. I believe Chinese phone is very different than what you see with like Korean or American smartphones. Um, the reason why our market doesn't really support it is because there's some concern about the standards and the things that are equipped in some of these phones. It was released for a short time and then it got taken off the market because they found some firmware manipulation in on these phones, right? And similarly, you do see some of this with IP cameras and some of the things. Not just to call out manufacturers that are producing their product in Chinese, um, companies, right? But you typically see that that's a mass market. China dominates the technical production in a lot of the hardware, and it's very cheap. So what happens is even if you have an American company or a Chinese, a German company, for example, they might buy hardware that is produced from China or in different part of the world, and sometimes they inherently have firmware issues. So when you work with IoT devices, this is a very needed area in cybersecurity, right? Like a lot of people get into like your blue team in defending your enterprise and so on. And this is a special niche only because when you get into IoT pen testing and security evaluation, you have to be good at hardware and you have to also be good at software level. Sometimes you will have to reverse engineer a lot of these things to find out like the problem. So you know, and then you have to know network communications and other things. So if you're looking into a specialized area, right? Supply chain, industrial automation requires that you have knowledge in IoT assessment. I think there are some new certifications that really address this, but it's not a very big area for general cybersecurity professional. So you have specialized people that work in this, and you have specialized security service company that house these people. And so if you are thinking about an area in cybersecurity that you want to get into, potentially this is a very rapidly growing area. That's what I recommend. So in cybersecurity profession, a lot of people think that, oh, you either become an ethical hacker, you become a blue team person where you defend the network, or, that's a typical background, right? Forensic is a little bit more rare, but you have to really think about like, what do you want to focus your expertise in? And that's going to leverage your salary down the line, right? So you have to build the skill sets in order to do that, because a lot of these courses are going to give you some background in it, but you have to play with the tools, with, the components to really understand it more. So if you like electronics, which I do love, right? Things like Raspberry Pi, sometimes I use microcontroller and I like to really, evaluate it and program it. This is an area that you can get into, and understanding how operating system work for like embedded Linux and things like that. That's helpful too. Okay. All right. 5 or 4, right? Why is IoT attack surface different than other server and other system attack surface? Because IoT has very limited hardware. You typically see a board. I should have brought some of the boards. And a lot of these IoT devices now are capable of, integrating AI. That means that you can incorporate LLM with it, right? Like when I taught last summer, I built out Raspberry Pi 5.
and then we train it. We made it into a chatbot, and then we train it. A lot of the times you just need Python for AI, right? That's the typical language. So you have software capability, but the software is really written for specific instruction, right? Um, the device itself might not have like a major set of apps like what you see on like tablets. But what you see is that it does have some kind of software in order for it to work. For example, like your IP camera does have that. Like an app for you to manage your power and your storage and so on. So it would have generally a chip that is for power. So when you're looking at a board, unlike the regular motherboard, you have like the functionality in like typically you see like an amplifier to be able to generate or control like how the signal is received. You have a main processor, you have internal RAM that's on there. And all of these IoT devices have a communication interface. So that means that it has a wireless chip or an adapter that's already integrated, right? And if it's wired, right, that's typical your Ethernet connection. So when you're looking at a Raspberry Pi, for example, that's more of a compact device, right? It runs ARM Cortex, and with that, like now it comes quad core, and you have at least 4 gig of RAM up to 16 gig of RAM that is internally built. So the more you pay, the more RAM that you're going to get. And the more RAM we have, we can run more application and software, right? Software depends on RAM. But because of the limitation in the hardware itself, right? There's a lack of security measure and feature that can you run antivirus on these things? Yeah, I mean, if it runs embedded Linux, like the Raspberry Pi, yes, you can run an additional application. But if you dive like a little bit more left into things that are specific for the functionality, like your IP camera, you can't really run security software on it, right? You just hope that the patches and the updates close out the security issue. So that means that the attack surface becomes different. Even though it might use protocols that are similar, it might have communication to the network, right? That is similar to your regular systems, but because the processor are instructed a little bit differently, and so on. So your attack surface becomes bigger. Okay. Everybody now allows you to connect your device in your greater network, right? At an enterprise or a business. So when you have a bring your own device to work, typically you need, from the perspective of network administration, you need to make sure that you have some form of protection for these devices, right? So the standardization in the operating system itself, right? If you're looking at like the iPhone and different models in the iPhone, that means that, if they're not all running the same operating system, and then you have the Android, there's like different versions of Android and different manufacturer of Android systems, right? So the vast in diversity in that it becomes a lot more complex in how we manage the larger network with bring your own devices to work. You typically see that you are more prone to malware and you're more prone to attacks, right?
So what do you prefer?
I am a true Android user. My husband is not. He is a true Apple user. Yeah, I believe that there's quality in Apple products for sure. I'm PC and Android, right? I buy Apple products for family. The only thing that I would probably lack of is like FaceTime, but you can use other applications for that. Yeah, so or like airdrop stuff, right? It's kind of nice to have like different type of service with the actual device. But I really love my Samsung products because it's seamlessly sync all the way through. And then when I upgrade, all my profile, everything carries because of Google. And I push a lot of things through Google. Yeah, they gather your data and everybody does. Apple does too, right? It's just, I think the Apple devices are very expensive I mean, it's quality, but they really capitalize on fan base, right? They announced that they're gonna change ports and cables, so to get the user to buy more. But if you're looking at like just the wireless headphones, right, that's used, comparing that to something like Bose or Sony, right, it's tremendously more. So yeah.
I will say Android, you can do a lot.
Yeah, there's flexibility in the consumer world for Android. Um, okay. For 6, explain why attacks in IoT devices are greater impact in healthcare industry. And as I mentioned to you, right, healthcare industry really push a lot of IoT device use for the operation. Um, what happens is that because the devices is produced and with poor design and sometimes they can malfunction, it causes severe consequences. So if you're looking at heart monitoring devices, which is very common in hospitals these days, right? So if you go to the cardiology wing, you typically would see a lot of, like, if you go to ICU, they use a lot of that there. For patients who came out of surgery and they're still recovering from maybe a triple bypass or a double bypass, right, whichever. And they need to be monitored so to make sure that, like, their health is still good, right? The heart is functional. And the data is useful to the physician because a lot of them, they might be given specific medications for the health conditions or the heart conditions that they have. So, and some of that plays into pharmaceutical study and medical studies. So what you see is that if these devices are not connecting properly or sending the appropriate data, right, it jeopardizes people's health. So it's so important, right, in our world from the perspective of support and maintenance, and securing these devices and making sure that they're available, right? That's important for consideration. So it's a lot more than just a device that monitoring, right? It helps people as well. Okay. Now, when you have the older devices, they eventually don't have software updates. As you know, that if you don't have the appropriate operating system with embedded Linux, right? That's why I make you guys do the updates every time you install software. Linux development and application in Linux are very specific to the kernel of the OS. So if you write a new software, right? Typically you have to parallel that with the existing current kernel for the operating system. So if the device stop updating the operating system, right, or the hardware is too old to meet the requirement for the new software, then it becomes very vulnerable in the network. And the downfall is that a lot of business, they don't upgrade if the things are still working. Let's say that you have a company that use IoT devices for manufacturing, and it costs them millions of dollars to implement these devices. They don't just tear it out and put new devices like every 5 years. Sometimes it goes longer, right? And the longer you go, the more vulnerable you are in the IT infrastructure. That's the way we look at it, is because security software updates close out security gaps, right? Like services, protocols that are being changed, standards, right, that you need for communication. So when you're looking at Bluetooth in itself, right, if you bought a Bluetooth device, let's say pre-COVID, a lot of times you can't use it with the new Bluetooth standard because, right, that standard went away. So what happens is then you have to buy new devices in order to accommodate that, right? So in a lot of cases, what you see is that they are being targeted a lot more in our environment compared to what you see with your, other type of systems. Okay, so these are some areas that we want to see. So the types of IoT devices, tactics that can be performed to on the common vulnerability. So typically, most of your IoT devices have weak password or a PIN, right? If you're looking at a tablet, typically, like your smartphone, like I use Android, so typically that's just a PIN, and the PIN can be enumerated, even if you have 5 or 6 character. I use biometrics with it because it's just another layer that we can slow down the attack process. But anything that is password oriented or PIN, you know that we can brute force, right? So from a security perspective, if you have the resources and time, brute force becomes easy, right? And then dictionary is just using common dictionary-based passwords. And then rainbow table attacks, just using like the hash functionality or having different tables to correlate for the brute force purposes, or password attack, I should say. A lot of them use cloud storage. So I have completely wireless IP camera. This is my third set, right? My first one, I found out that somebody was in it, that was wired, and then I bought some Chinese-based one that is completely wireless and solar. So I don't like, because the way I look at it is if they can remove power from your systems, then they can make that system become unavailable. So all of mine are solar based. So what you see is that my camera pushed my video, right, to the cloud storage, and from the micro SD. Then what I have to do is I have to pay for the encryption when it does that and where it's stored, right? So yearly I have to pay a subscription. So typically if you don't, a lot of these things, you already know, people post like video shots of like Ring camera, right? Because it's open to the public. A lot of them use OpenDNS type of servers, and that can be accessible in some sense, right? If you're not familiar with Shodan, you, I introduced this in another lab in another class, right? But Shodan is a search engine where you can find vulnerable devices, because they're all connected to the network. Okay, we talked about outdated software. So firmware manipulation, they can also drop a backdoor. So backdoor is just sometimes it comes as code, right? Sometimes it comes as like an account where they can come back in with no authentication requirement. Typically, backdoor was created for developers to go back and do maintenance on the systems or the software. Backdoor is not as predominant like it was decades ago, but it still is a form of attack. And then denial of service and 0 day. I think we touch on that, right? Playing on the vulnerability, or just generate a lot of the requests to make it unavailable. Now, if they're connecting to the network in an insecure way, right? They can remote control. I've seen many cases where, their people's camera is being accessed by other entity, right? Or people controlling smart things like smart thermostat. So you don't want operating system level control, because that can change the dynamic of how you use smart things, right? You have from smart refrigerator to appliances now that all talking to your network. I have cats, so I use robots for my cat litter, and I don't connect them to the network, but I typically feel like those things are so vulnerable because, they're not too expensive, and even with the expensive one, they're probably not designed with the best security in mind. So, and then you can also have impersonation. Typically, impersonation and man in the middle and eavesdropping go together, right? They are intervening or intercepting. They pretend to be you, right? Or the entity that you're trying to connect, like the server, and then they would capture whatever your credential, your access, your data. And then also lack of encryption causes data exfiltration, and similar to the others. Okay. Now, physical tampering, a lot of them start with things like disconnection, right? So I came from networking background. I was a network administrator for a long time, and I used to tell my team that if someone walks by and unplug your cable, you're done, right? So in the past, if you notice, every time you drive by a train station, these little boxes that they use. Did you know that those boxes are really important to the train system? Is that it controls like how the track connects, right? Now they regularly drive in a truck to monitor the actual physical security for the train tracks. In the past, that wasn't done so often. And what had happened was someone had accessed these bots and control them, right? Logically access it and physically access it. So now what you see is you see the physical security for these boxes, right? Because imagine if you are riding the metro, right, and then something happens to your train, like it cannot stop, it went on the wrong tracks, right? That can be very chaotic and deadly. So physical tampering is like one of the area that we really focus in, especially on industrial system, because industrial system relates to transportation, to the grid, right? Your gas, your utility, a lot of these things tie back to IoT, and it can be scary. Okay, so the common signs of IoT devices compromise include, right? If you assess these devices, if you see extra processes utilizing a lot more power, it's running extra tasks, right? Sometimes that could be malware related or attack related. If it's using a lot of bandwidth in your network, that is typically data exfiltration or someone is accessing it remotely. If it becomes unresponsive to the typical function, right? Let's say that you're trying to change the temperature on your smart thermostat and it's not responding to your request. And then unknown request message, right? That would be the anomaly in these devices. Or you also have accounts that are unknown or you did not create. So unusual accounts. So when you audit these devices, typically we look for those things to make sure that they're not jeopardized. So how can we improve the usage in IoT? These are just going to reduce your risk. Okay. So if we reduce the vulnerability, right, and that really kind of reduce the attack surface, and that's going to help you a little bit with more time, right, to utilize these systems. So the practice in using better authentication, using multi-factor, even with multi-factor, you know that it's not fully safe, right? Having strong passwords and using other factor in the authentication process like biometrics, something you have like email or other devices for communication to verify. Update your software and firmware regularly, disabling apps permissions and also disabling apps that you don't use. And this goes for all your smartphones too, right? Because some of these comes with additional apps that that comes with the operating system. So if you don't use it, you can turn it off. And then use VPN for wireless connection. So this can be a subscription or you can set it up with your general enterprise network. So in just like all the other system, when we are modeling out the risk for these devices, right? We have to really focus on how they're designed, right? They are more compact, like what we said, right? And they typically run a different form of software and operating systems. Now, if you model it like your regular computer network, what you see is that it will not work because there's so many different types of IoT devices and different software and different hardware. And in the design itself, it is more challenging to really fit the model of risk into what you see in the IoT network. So when you're pen testing IoT devices, just keep in mind that you will need more resources and time, okay, to really understand the engineering of the device, right? The design of it, the hardware it uses, the operating system, the applications, and to really understand how that plays into security, right? So that's why we make you take hardware classes like CIS25. But learning about the regular computer can correlate, right? I really think that if you are good in hardware in general, your IoT career or your IT career or your security career is generally pretty okay. Because a lot of it comes back to like your very basic concept, like what makes a system and what is an operating system, and how it use resources like RAM and processor. Okay. Based on the IoT attacker model, identify the physical access based on the given scenario. So when you go to the grocery store, right, or Starbucks or any of these, right, when you walk by cases like refrigeration cases, all of those have some form of control, and typically they use microcontroller. Some of them use embedded system to be able to control the temperature, the moisture for specific products, and it typically centralized back to some kind of console on the network, right? So if these devices or things have the controller is open to access, the attacker or someone who's malicious can have physical access to it. So if they cannot logically connect to your system to perform the attack, typically they would try to physically attack it, right? Like I talked to you about like that box at the train station or the train tracks. So if they open the enclosure and look at the components within the device, right? And locate the interface to be able to pull data or information, this is called invasive attack. And the key word here is opens and enclosure. So if they physically, right, open it up or access it, the components within, then it's invasive. Now, if they locate the IoT devices, but they're not able to open it, let's say that it's a camera that's mounted high and they're not able to unplug the cable, right? But they're able to see it, right? And then be able to identify which one that is, and that is connected to which network, right? That is a non-invasive access. Okay. And if they can connect to the device through the wireless network, this is called local access because they have to access that network in order to connect to the devices of that network. And then if they are remotely controlling the devices from another location or another country, that's called remote access. And you typically see this with IP camera, a lot of it, because they are the most vulnerable in our environment, right? We are so used to like adopting these things into our life, right? Like I know people and I see people using things like Alexa and even like my smart TV. I don't command to my smart TV like how people would with Alexa, but it's listening, right? So the microphone signal is always it's there, right? So some of it now is that they are pulling your data from your conversation and things like that. So and we waive our rights to use these appliances and devices and the service. So we are opening to more risk. Okay. And when they're remotely controlling your system, it's a lot more. So imagine if you have camera inside your home, right? And they're able to see like what's going on in your home, right? That can be very invasive and scary. So we have to think about like the technology that we use, right? How it impacts us and what kind of risk it's going to impose. ultimately technology is to help our lives, but at the same time, there's negative aspect as well. Okay. For 13, why are IP subnetting, network segmentation, and port controls ineffective in securing these devices? I just talked to my 41A class last night about this, right? Like if you identify there's an indicator of a threat, you need to make sure that you isolate that. Just like how when someone is very ill, like if they got some kind of disease, right? And they go to the hospital, they get isolated because you don't want other people to get affected by that illness. And similarly in security, when we think about like if a device gets attacked or a system like a server gets attacked, we isolate that. We put it on a separate subnet. We use different IP address so it has to route back into it so we can see like, what kind of attack that is. And so we can stop the attack, right? But at the same time, when you're thinking about IoT devices, can you use the same approach? A lot of it is that because they are using sometimes different services and protocol, and they're outside of that control zone that we typically see with like wireless for laptop or systems, right? And so the authorization for access in the app of your smart devices are also different, right? Because the components that it uses. So the level of access in the network system, yes, it is integrated with the network, but at the same time, we cannot use the same control implementation, if we throw it on a different segment, right? By itself, a VLAN, yeah, we can monitor it a little bit better, but a lot of the times these are wirelessly connected. So when you manage a wireless network, a lot of the time you set up zone. So for example, when you guys are here, you're using the school wireless network, right? You're on a specific zone. They're looking at that, right? Even though it's like open. And so with that, you're authorized to access the majority part of the internet and so on, right? But there's certain things that are going to be screened. So what you see is that the access level of these devices, because of the hardware components and the functionality of the device, like the app that uses, like Google Map, okay? So turn on your geolocation so that way it can give you like the nearby streets and so on. That's not always the case when you're looking at like servers, right? So drastically different in the functionality of how we use the system. So in your regular control implementation, it might not fully, can be successfully integrated. Okay. So for 14, IoT access level would allow, which IoT access level will allow privileges for debugging, examining source code, or root level access to firmware. Typically, you see this as manufacturing level, and they have root access, right? Because, in the case that if they need to reset your system, if they need to fix your system, right? So they are able to have a higher level. So root is gonna be like the highest level with full control. Whereas as a user, you typically just interface a system. So there's two areas like what I mentioned before. When we were looking at a system, you got the system level access and the user level access. And when people design operating system, you see that, right? The system access has a lot more control because it needs to be able to initiate services and things like signal, right? For just like keyboard or like touchscreen, things like that, or microphone, speaker, power. So there's like a lot of different functionality at that level of access. But the manufacturing level access, because they need to be able to accommodate the software, right? And the firmware level, it is higher access. We need to know this because in the case that like if they root your system, I know some of you have root your systems maybe, right? You have a higher level access, but manufacturing level access is open sesame, right? So if the attacker gets this privilege, then they have full control of your system. They can't. The reason why I'm kind of speeding through this, I think I mentioned it at the beginning of class for some of you who came in. I'm gonna try to cover Unit 13 lecture today before we do the lab, so that way attendance is optional next week, right? If you want to come in to make up the work or, have questions or concern, I'm here. I'm gonna be here during the finals week too. You can, right? So because gas is really expensive, and I know your time, and so we're gonna try to address that today. We're gonna do our last lap today. And then if you want to come in to do some makeup work or review something next week, you're welcome to. I'll be here. Okay. All right. 15. How should the components be mapped to the authorization access level for the IoT devices? We really need to think about the permissions of the individual component in the IoT devices, especially when it's trying to have a higher access level. And keep in mind that you have applications that would require components to access at a higher level, right? Like geolocation, like microphone. So you ask yourself, should I give this permission to this app? Now you're able to do that for the time that you use, one time only, right? Or forever. Now, if you do that, because it's always going to have this permission, if you give it forever, then that component is always going to have that signal, right? It will be listening to you. Now, in some cases, we don't have a choice, right? I'm always wary about smart appliances because of all of these things that are happening in the back, right? So what you need to do is you really need to think about, like, what should I authorize, right? What kind of permission should my device have? And you have to drill it down. And in the mix of type of environment, it's going to be a lot harder. So when you're looking at enterprises, thousands, right? Compared to at home, you might have only a few. Any question? Okay. So we can check out the notes. Okay. And it talks about like specific and give you some examples. So let me ask you this. Drone, right? They become more predominantly used in our world, and they will stay, right? Our government use drone. There's consumer drone, right? There's some regulation in where we fly drone, what kind of usage for drone. Industrial drones are different than your regular consumer drone, and they have specific, and they are wirelessly communicated, right? People record videos on their drones. That was the issue with the fire, why they took so long because it impede the helicopter, because people were flying drone with the Riverside fire. But anyway, so what you see is that you have these smart devices now, right? That can be automated, that can fly, that can go, and when you're looking at smart cars too, right? But they impose a lot of risk. So we have to really consider, like, what kind of activities that is happening on that system and how we interface it and what's the service in the back. Now, all of this is coming back to the convenience of technology, right? But in itself, it really pushes the security direction in a different path, compared to what you see the traditional cybersecurity is really focused on, like the rest of the enterprise network, the infrastructure, and so on. So if you want to get into this for industrial system, learn about Zigbee, right? A lot of them have Bluetooth capability and other standards. So it's beyond 802.11. So, and then some of them use near field communications, like what you see with, with the tap to pay and so on. Any question regarding Unit 12 assignment? Okay, let's do 13. I think I put it on my drive. And then I will try to get your pen test plus up tomorrow. I'll try to fix the problem tonight or manually put that into Canvas. And you have multiple attempts with that. So the goal is to get highest scores possible, right? Eventually, I want you to consider sitting for these type of certification. If you want to get into ethical hacking or pen testing, that certification really speaks to what you can do in the industry. So it's a big push, all around. Oh, maybe oh yeah, I did have it. Okay. So let's look through 13, which talks about cloud. So in the past, I've written many cloud labs, right? The challenge, like I mentioned before, is typically you have to have cloud, even the free subscription, sometimes they make you put in a credit card. Microsoft Azure allows students to have an account, but it turns out that like we don't have that enterprise license at our college district. And you need to have like a GitHub enterprise license, which ties back to so you can sign up. Some university supports that, some school supports that. But let's talk about cloud attacks. And cloud is very common. Everybody uses it because it saves money on buying the servers, the racks, the network systems that we need to house our servers roles and the data. So things like AWS, Microsoft Azure, or even Google Cloud. So you predominantly see for here, right, in technology, Amazon Web Services, AWS, and Microsoft Azure are very common, right, for the IaaS type of service. So if I want to rent someone's hardware to put my network systems on, my servers on there, I can, instead of buying the equipment, right? So that's very popular. Now, question one, it says, why do attackers target cloud? And what kind of results will you have in cloud attack? Because the service platform and the computing services, hosted application and storage in the cloud is vast. That means that I can run a complete network by renting someone else's systems. I can have entire school networks with all the applications hosted on there. I can also have a manufacturing company and use, automated functions for my systems to produce goods via cloud package, right? So similar to what you see in a regular network environment, data exfiltration is the number one area for cloud. So they would go in there and be able to pull things like patient's data or students' data, right? So, and then, or corrupt the data. So you either have data leak or data loss, okay? Now, if your cloud servers are your backup or your failover cluster, right? And if they attack that, your backup systems, meaning your failover systems will not be available. So in the case that you have your primary system server crash, that can create problems, right? Unauthorized access is typically an area that someone would be able to get into the system. So an account is made, and a lot of it now is coming from spear phishing, right? Targeting certain technical person, be able to access their account, create another account that has a higher level access, and go in and start navigating through the network, right? So that's a lot easier than when you're trying to brute force or you're trying to perform the attack, not being on the inside. So they want to disrupt the services. Now, when you're looking at like smart vehicle, a lot of the information, like if you're looking at like automation in like driverless vehicle, right? Some of it is coming back from network control. They have their own network and it's using data center information to provide like vehicle safety. So the sensor and all of these things pull the data and it feeds that to, the server that is managing the vehicle, and it's, like traffic conditions, customers, how many people are sitting in the car, whether they're wearing seatbelts. So a lot of these things come back to what you house also on the cloud, right? So the typical form of attack with cloud services and systems is denial of service attack, and that plays on the disruption of services. And that can be very dangerous. So in the case that if you're looking at unmanned vehicle, right? If the main system, if the controller system becomes unavailable, then accidents can happen, right? Because the communication between the server, the controller servers to these vehicles needs to be available at all time, right? Locally, the vehicle, it have instructions for safety, and I'm sure they tested that. But a lot of it is going to come back to things like if you have Uber, right? They want that data so that way they can provide appropriate services, transactions, and other things. So denial of service attack, account hijacking. So that means that someone can take over an account, a user account, and typically it start with account compromise. They like to put malware, and you already saw that with Canvas for sure, right? That's through the web application that is connected, and they house that at the data center. So ransomware and other form of malware like Trojan. Trojan is typically used for like phishing or disruption services. And then sometimes you would have insider threats. Those are the people that is leaking the data from within or manipulating the system and so on. And then you have side channel attack, cookie poisoning. The reason why is that a lot of our web services, right? And web servers and web application uses cookies. So if they poison the cookie, right? They modify the cookies. It causes redirections and other things, right? Or crypto mining. So you see some of this now. And then we talked about 0-day with IoT. So you do see some of this, but everybody has a database, regardless whether you use relational or not. So even the cloud itself, right? User accounts, if you're managing like IAM, which is user access on cloud environment, that platform in itself, it is actually like a database of user accounts and the privilege and permission. So injection. So how do they perform side channel? You saw this in the last question. You're wondering, what is side channel attack on cloud, right? So we know that cloud is just a set of servers that are remote that we need to connect to it via the larger network, like via the internet, we are service provider networks. So the way that they can perform side channel attack is to place a virtual machine that is malicious, right, on the physical host that's used by the cloud customer. So let's say that you have an administrator like me. I use Windows, so I would RDP. I use remote desktop protocol to be able to connect to my cloud systems, right? My instance could be another virtual machine. So that means that if my system is jeopardized, they can put a virtual machine on my system, and through that virtual machine, they're able to see, right? Like how I connect, what configuration I have, and so on. So this is a way that they can access information from my systems that is connecting to the remote server, okay? Because typically I would have a session to, if I'm using things even like SSH, that is secure, right? But the encryption key for that secure session is on my system, right? So that way my system can talk to the cloud servers. And so if they are there in my system, then it's jeopardized. That's called a side channel attack. So the goal of this is to, again, right, pull sensitive information, maybe configuration, password, encryption keys, like what I talked about, sensitive data or find ways to disrupt the services or manipulate the behavior of your cloud systems. So you see that the more advanced we are with technology, the more advanced the level of attack, right? There's always a way with resources and time. I'm sure you guys read a lot about AI attack lately, right? Like Mythos, and so those things are going to be predominantly in your world when you get into the field. Okay, so why are cookies targeted with cloud application attack? Because cookies usually contain user credential, right? Preferences and browsing history. It's hard these days when you access the internet and not, right, allow cookies. You can allow the essential cookies for the functionality of the website, right? But a lot of them use your cookies to understand, right, your browsing behavior and personalize your experience, okay? So if the user has a personalized experience with a web server, right, because cookies are used with activity tracking, those cookies can be changed. That's called poisoning, right, for application access. And the way that we interact with the internet is through the browser application, right? So, because cloud is, we have to connect via the web, then that's what you see. Then so how do they gain access to crypto mining? Crypto mining can be popular in certain part of the world and it can be popular in some network, right? You don't have to have a super powerful system. You can use system with GPU. You can use your CPU to mine crypto. Some people use Raspberry Pi, right? Some people use gaming computer. In different part, like if you go, I don't know if you've ever seen like documentary on Netflix or other sources about crypto mining. There are farms, right? Crypto mining farms. These are like data centers or warehouses that they have systems that specifically focus on crypto mining. Is it completely illegal? Not really, right? In some places, depending on the location. China alone, in some city, that was the focus, right? They built these warehouses for that. Some part of Washington State and Oregon and even, and people do it at home or people do it as a business, right? So, from an attacker standpoint, why do I want to get access to crypto mining systems? It's because they want the crypto, right? The currency that is being mined. If you have the resources, enough resources, eventually you'll be able to find some cryptocurrency according to, a lot of these theories, right? So if they are implanting malware or if they fish out credential, right, eventually they can log into these machines that are used for crypto mining. And that's typically the base in crypto mining attacks. Any questions? I mean, the market for cryptocurrency is not as high as it should, right? As what you would see, that for some people who invest in cryptocurrency, that's what they would want. But at some point, the high, if you're looking at Bitcoin alone, right? A coin is worth a lot. So compared to how it started. So definitely there's an incentive for crypto mining. So how can we reduce some of the risk? Some of it comes from misconfiguration. A lot of it is like the services and the protocols that we use. So make sure that your access is managed. So we are using least privilege principle. We want to authorize specific groups and users for cloud administration and management, right? We want to change the default settings and customize it so that way our system and applications have security or a little bit better than what it comes with. And we want to configure settings of the systems and think about like how the application is designed for the use of operation in a secure way. So you have to encompass a lot of things, right, to be able to accommodate cloud security, from services to software, right, to configurations to user management. And we call that defense in depth, right? When you overlaying a lot of different things to make sure that you're secure. It's like at home, right? Locking your door doesn't necessarily prevent people from entering your house, right? So you have to think about, oh, maybe I would put a gate, maybe I would have a dog, that, you know, would sounds off the alarm. Maybe I need to make sure someone is always at home. So those are the things that you have to consider when you build out security solutions. And this is just network system elsewhere, right? That we acquire or we rent. So I recommend, okay, this is my recommendation, because if I ask myself, if I start all over again as a cybersecurity student, what kind of skill sets would I need? Cloud, right? If you can get certification in cloud, I know we're running 48A this summer. That's a Cloud Plus class for IT project management, but having cloud knowledge and be solid in cloud, and if you can get into cloud security certification, I highly recommend it. Microsoft does a series of it, and there's other vendor too, but you can go with CompTIA to do just like a Cloud Plus. I think they have a cloud security one now. But that is going to leverage jobs. Whether you are transitioning to IoT, application assessment, whatever that you're going to be doing, everybody uses cloud, right? Like predominantly, I want to say the majority of business use cloud because it's cheap. And you know, and it's here to stay. Cloud been around for a long time. It just we label it cloud now because the internet cloud, right? But it's been around for a long, long time. Okay, let me move 6 down. Okay. So in cloud attacks, right, how do unsecured APIs become exploited, and what are the results of these exploitations? So we know that API is application programming interface. It's a way that we can integrate a program with another program. So for example, I might have a web application for my bank, and I would integrate AI chatbot API, right? So that way it can provide some basic answer to my customer. You see a lot of that now because it drives the marketing for the business. It, you know, it makes your company more well-rounded because you implemented the current technology. There's a lot of aspect in how we would use these type of technology, but when you're using insecure API, they can definitely, because it's just software, right? The attacker can gain access to the system that way. They can leak data and they can disrupt your service through the API. So when you use API, you would need to have a key, right? So a program needs to talk to another program using that key. It's kind of like how you are able to connect, right, one system to the next. It's same thing in that concept. So the program itself needs to talk to the other program, and the way that it does that, it in access is having that key, right? Just like a long string. Um, an example is like Writer's Total, right? If you want to use that with your security application, you can integrate its API key with that with your security application. Now, there's a thing called Shadow API where they can obtain the functionality of your application to really look at, like, you know, what kind of data. All application is using data because it's how data input and how data output, right? So whether you're looking at native application or web application, in that case, you need to have some form of data access. Whether it's temporary, typically it's stored into RAM and then pull that and put it onto a database, right? So if they exploit the parameters of the API using code injection, then they would be able to access your application and your data. So API is a big matter these days because everybody is in a race of integrating generative AI API to their platform. So any question? Okay, so we know that cloud is a service, and then there is microservices in the functionality of your on your cloud. So and actually why is microservices management needed for cloud platform security? Because if you don't manage your microservices, right, your workloads for your systems will be exposed. Okay. That can lead to attacks that you will not be predicted or be detected, and it opens up more surface for attack. Like that means that they can attack you more successfully, and it's easier for them to perform the attack. Any question? Now, why aren't people using Google Cloud as much, right? You are familiar with Google Drive. I think the majority of it is used for like storage, like data storage. Google Cloud, it really emphasizes for enterprises like applications. So if they're running application servers and things like that, typically that will be Google. But a lot of the cloud services that are in the enterprise network are for infrastructure, right? IaaS. You do see other options like SaaS, like software as a service. So software as a service, yes, you can go with Google Cloud, but AWS and Azure, which is Microsoft, predominantly is for all areas of cloud, storage, infrastructure. That's speaking about North America or United States, actually, because other part of the world is different. Okay. So there was a case study. This is a very well-known attack, right? Cassia attack. In this case, right, the attacker got administrative control. Typically, in a successful attack, if they have administrative control, because it's full control to your service and your system, like to be able to modify configuration, right, modify your system settings. How do they gain administrative access? And what is the result of the attack? And how can they implement future, how can they prevent future VSA attack, right? So how they got in was to place ransomware. And this disrupt the service for the customer, right? So this is like a cloud service company, a cloud provider, just like how you see with AWS, but it's for other part of the world, right? So they place a ransomware, and ransomware typically encrypts, right? Storage, that could contain drives that could contain operating systems, data, etc. And that caused problem because the disruption. Then they took down the software as a service application. So these are web application servers. And that changes the actual physical system and the virtual SANs appliances. So these are appliances that are for storage, right? And this impacted 10 countries. So the outage not just impact one company in one country, it impact many companies in 10 countries, right? And so for virtual SAN appliances, now what they're doing is that they are implementing a detection tool. So that way, as a business, if I subscribe to this provider, I'm able to monitor and I will be able to have notification in case that there is a VSA attack. So because of this attack, that's how they learn it. And for many cloud company, this was not an attack before this, right? So for someone to perform this kind of attack, they really have to understand like, the services, how it's hosted, communications, right? And, placing the virtual appliances. So it's kind of like what we talked about before on how they would use virtual machine, right? So virtual appliances are logical systems that is placed onto the actual physical device, like a storage server. So now they're able to analyze it. So this becomes available after this form of attack. And with that, you can see that it is reducing some risk. And just like all technology company, right, they are targeted. So Facebook, cloud attack, there was data leak of millions of users through the exposure of their database. Facebook is now Meta, right? And if you're looking at their data centers, they have quite a few data centers. You can go to their website and they actually provide the information based on their actual physical data center in different part of the world. Long ago, when Facebook started to become very popular, I have watched a documentary on how they build out their data center. It's very interesting. From like, how fast can their technicians service each, how when you upload a video or a picture, right, to social media like this, they do hot swap on the drives, right? So if the drive is full or it goes down, they receive a notification. They technically have less than, I want to say, 7 minutes to swap that drive. Okay. So at the data center, the technician pushed the cart and then they go and they just pulled out the drive. So hot swap means that you can take out drive while the system is on, right? And you throw in another drive. And so with that, like, so that way it's seamless, right? So there's another server that's picking up your upload, and then it transferred that file into your storage for your profile. And so these drives are used for your storage for that. And some of their data center, it's water cooled. So they use like, water vapor to be able to cool a lot of their systems. So it's really interesting. The biggest, I think their North American one is in New Jersey. And then you have another one here in California, right? That's Mountain View is where their hub originally. So, and then you have like different part of the world. So, all right. The vulnerability that's exploited in the Cognite cloud attack. What is the result of the attack? The reason why I share these study cases is because you see a similar common attack that is escalated from this form of attack. So we learn from the prior historical attack. A lot of them related to data leak, and data leak typically ties back to database, either injection or some form of access, right? And now you see things that happen similar to Canvas with malware and exploitation. So database lacking authentication and 5 billion of record of users were made public. So in the case of ransom, if you don't pay ransom, that's what happens, right? Sometimes they don't demand a ransom. Sometimes they're just like, oh, I can do this to show that your company doesn't have security. Okay. And then sometimes it goes onto the dark web to be sold. In RayChat attack, what type of vulnerability was targeted by the attackers to expose the data? So for NoSQL database, MongoDB, there was misconfiguration with these database. So no matter what kind of product that you use for your database systems, you are still vulnerable, right? If you don't configure properly, if you don't have proper security with your database, data is so valuable these days, right? That's your primary assets for most part in the system that house the data. So another skills that you should learn is database, right? Whether you learn MySQL, Microsoft SQL, MongoDB, but learning how to query data, how to manage and set up databases, right? When I taught Python before, I used SQLite with Python, so you can build an application and put a little local database to be able to make your application talk to the database. So that's kind of cool. You can do MySQL with Java. There's a lot of options. So this summer, if you have nothing to do, right, take a database class or learn database. That's going to go a long way in your career. All right. Let's take 12 down. So what type of security measures should be used to protect your cloud data? So if your data is at rest, that means that it's stored, it's not being opened, it's not accessed, right? Like archive data. Files that we store from a few years ago, right? So stored data you should encrypt, especially if it contains sensitive information. You should use a different type of encryption for data in transit. And typically we see things like using TLS or SSL to be able to encrypt data that's being transmitted across the network or into another network, right? Capitalize on HTTPS or the protocols that give you stream-based encryption. So when I say stream-based encryption, it encrypts 1 bit at a time when it streams, where data at rest, typically we would do a bulk encryption. So that way it is, more ideal, right? You're not accessing the data, so you don't need fast encryption. So data in transit, you need fast encryption. Okay. And then also data in use. So in the case that for data in use, the user would then, let's say I am an engineer, I would open up my engineer plan for a certain system, right? Or product. And then when I'm done, right, that file is then encrypted. So in order to access that private engineering plan, then, it needs to be decrypted. So you have to have keys in order to access it, right? And that is just another layer that we can protect the data. So in security, we talk a lot about like, oh, how can you prevent this from happening, right? That's preventative measure. And that's where you should be operating. But when you are combating attacks that's happening now, that's reactive. So that's not preventative, right? If you have preventative, then you would have less reactive security. And that's the goal in security, is to have more measures so that we don't have to combat attacks and malware and a lot of the things that are happening in our systems. So encryption is probably the base in a lot of things, encrypting communication, encrypting your data, right? And then managing access control to the system that your data is stored or being used or transmitted. We need to make sure that we manage the services, like disabling the things that we don't use, managing the services accordingly, looking at the type of protocols that are correlated to the services, managing the data classes and how we control permissions to your data, managing the application that access the data. So it comes back to the core is your data, right? And then the API. So the application that talks to the application that uses the data, right? So in most cloud package, right, with service provider, you would see some form of management tool for security. And CSPM is cloud security posture management platform, where it allows you to monitor your threats from malware to attacks or attacker. And you can automate the response in the attack, like block, reject, request, right? If they're trying to submit a lot of requests for denial of service or get some authorization for authentication, right? You can use the system to manage your security. And then managing your cloud assets, and that includes not just data, but your virtual system or your instances, right? Your Docker or Kubernetes, those are your container. They're objects and subjects that exist in your cloud. Subjects are your user accounts, your groups, right? Entity on your that access your cloud systems, and then objects are containers. Systems are connected, virtual machines, and so on, right? And with that, you can reduce your threats. So think of this as like a centralized management for specifically made for cloud. Okay. It encompasses these things. So how can an organization address cloud security challenges, right? Making sure that your administrators are trained, that's really important. My generation, I think that we work with a lot of remote systems, but now you have a lot of different products and different services with the cloud for sure. And it's transitioned over time. So some of the people that's about to retire, right, might not have the skill sets. So they need to get certification, get trained. You can also have the provider for your cloud train your team, right? That's important. And that needs to be done more regularly. I think technology, you have to keep up with it. And then every cloud product that you see, right, because it requires access, you would see identity access management. So in an enterprise environment, you're going to have engineer that is going to be, or security professional that's going to be, this is their role, is to manage IAM. So when you hear the word IAM, right, it's identity access management. That's typically referred to access management for cloud infrastructure. And that will control what you can do on the cloud systems, right? That's called PAM, Privileged Access Management. And you should rotate your cloud access accounts. Okay. When I interviewed someone to teach here last year, I had asked him to do a demonstration on cloud security, and this is what he chose to do. And it was very interesting. He actually showed like his current job, what he was doing in managing like developers group compared to what you see with like other IT people. And then you should reduce shadow IT and making sure that it's aligned with your development mission as well. Your cookies were really good. Thank you. And then manage system and user access to fulfill compliance requirement, right? Every industry have some kind of regulations. Okay. Do you have any question for me? So what I did was I did 12 and 13 today. So next week is optional attendance. If you want to come and catch up with some work, you can. I will be here for the rest of the semester doing our scheduled time. Or if you have questions, right, you can always come in or, want to review or work on other things. All right. On the last questions for 13, and I'll get the video posted too, but I think those modules are open with last year videos now. Okay, so what I want to share with you is you can access this article, right? So Kubernetes are containers. We touched a little bit on this in the past. And when you say clusters are just basically group of containers. So system have storage components that are grouped together, considered clusters, right? For files, for the purpose of storage can be vast. Okay. So I wanted to share with you this article. It's a couple of years old, but you can take a look. And this was provided by Microsoft Threat Intelligence. So open metadata is open source platform to manage metadata for your data sources. And earlier in that year, they found vulnerabilities in this platform, right? And they published it. And so in April, there was an exploitation of that vulnerability, with the Kubernetes. Those are containers. Okay. So it talks about how the attack happens, right? The capitalization on the functionality of the attack. So in this industry, you also need to kind of be open to learn about different form of attack because you never know, right? It could happen to your organization. So whenever that they do a C2, that is a way that they can remotely control, right? Your data flow, your systems, your traffic. So when you look through the article, you would answer the questions. It asks you what is open metadata, right? How did the attacker exploit the vulnerability on this platform? How is malware used in this attack? Typically, you see a lot of that. Malware integrating with some attack tactics. And then the tool that they use to initiate reverse shell connection for remote server. And how can we prevent exploitation of metadata vulnerability? So look through the article. So it talks about the attacker's server hosts for crypto mining related malware, right? With Linux and OS, they use Netcat, which is like such an old tool. I think you saw the beginning of it. We use it to pull banners and stuff, right? At the beginning of the semester. And cron jobs is used for scheduling. You know how when you schedule your anti-malware to run in Linux system, you use cron jobs, right? That automates it. Okay. So the reason why they post this is, of course, they're going to try to market their product as well, right? So Microsoft claimed that their Defender and their cloud security components can help support, they are a very big player in North American cloud, right? So as a provider. So they have CSPM. We talked about that today, right? Microsoft Defender CSPM. So you see cloud products, you're going to see that they have CSPM to manage your security posture. And then these are the IOC. So when you assess threat, you have to identify your IOC. So they give you that here, right? Executable SHA. This is your hash. And then the IP information. And so if you house your cloud system with Microsoft, right, you want to kind of keep up with potential threats and vulnerabilities if you're using that platform. Okay. Any question? We have a general short lab today, but I want to explain. I was trying to work out some of the kinks with a really cool tool that runs LLM, but the required libraries that you need to install for that tool to officially work have some issues. And then I checked their GitHub thread. It seems like they're still trying to support it. That means that they're still updating it. So maybe that's more to come for other classes. Okay, so let's stop here.